Periodic classification of elements class 10. So in this session we are going to learn about Newland's law of octaves, merits and demerits of Newland's classification and questions. So my name is Mahantesh Shettar and I welcome you all to Chem is Try channel. So Newland's law of octaves. Before that, Dobereiner proposed his law of triad. So Dobereiner encouraged other chemists to correlate the properties of elements with their atomic masses. So later in 1886, John Newland, he arranged then known elements. There were around 56 elements known at that time. So from hydrogen to thorium. So he arranged all the elements in the increasing order of their atomic masses. Then what he did, he found that every eighth element had properties similar to that of first. So you start from the first element and go to the eighth element, both have the same properties, means properties are repeating. So based on this, he compared this to the octaves found in music. So we know Indian system, what is there? Sa, re, ga, ma, pa, da, ni. 7. So again, eighth will be sa. Means just like that, the properties are also repeating. So therefore, he called this as law of octaves. So how do you define Newland's law of octaves? So you can see this is a part of the Newland's table or whatever he gave. So sa re ga ma pa da ni and do re mi fa sol la ti. This is the Western music, 7 octaves. Okay. So he stated that when elements are arranged by increasing order of atomic mass, the properties of every eighth element starting from any element are repetition of the properties of the starting element. So how to understand this? See, lithium, you take lithium as the first element. What is the eighth element of lithium? So 1, 2, 3, 4, 5, 6, 7. Then eighth will be sodium. So he is telling that if you take lithium as a starting element, eighth element is sodium. So lithium's properties will be repeated by the sodium. Similarly, if you take beryllium as the first element, its eighth element from beryllium is magnesium. So the properties of beryllium and magnesium are similar. So this is the Newland's law of octaves. Then what are the merits of Newland's classification, right? So there are two merits. This system worked quite well for lighter elements, that is up to calcium. So starting from hydrogen to calcium, this is worked very well. This is one advantage, one property, sorry, one merit. Then it also correlates the properties of the element with the atomic masses. So in the previous slide we have seen that. Okay, so these two are the merits of Newland's classification. Then what are the demerits of Newland's classification? Why we are not using them today? Correct. So as I told you, it worked well till calcium. But what about after calcium, say chromium to zirconium? Not only this, there are some other elements. This is a part of his periodic table, as I told you. So this classification did not work with heavier elements, that is beyond calcium. And also, Newland assumed that there are only 56 elements existed in nature and no more elements will be discovered in future, which is actually not correct. Next demerit is he adjusted two elements, cobalt and nickel. See here, cobalt and nickel, both in one slot. Not only that, he kept those elements in the same column as fluorine, chlorine and bromine. So we know fluorine, chlorine, bromine are non-metals. Cobalt and nickel are metals. So both have totally different properties. Then he is the law of octave, he only breaking. So this is one of the drawback. Not only this, if you check, he positioned iron. So iron is here, which resembles in properties with cobalt and nickel. He placed it far away from it. So this is one more demerit of Newland's classification. Now, question time. Okay. Did Dobereiner's triads also exist in the columns of Newland's octaves? Compare and find out. So I could find one thing. See, lithium, sodium, and potassium, which is a Dobereiner's triad. This is also existed in the Newland's octaves. Second question, state Newland's law of octaves. Okay, which we already know that if you arrange elements in the increasing order of atomic mass, first element you take, eighth element from that element will be having the similar chemical properties, means repetition of the properties. Second question, what are the merits of Newland's classification? So, as we already studied, there are two merits. One, it worked quite well for lighter elements, that is up to calcium, and also it correlates the properties of elements to their atomic masses. Third question, what are the demerits of Newland's classification? Or it can also be asked, what are the reasons for discarding the law of octaves? So there are four. It did not work beyond calcium. He assumed there are only 56 elements. He placed cobalt and nickel in same slot and along with FCl and Br. Okay, then iron, which resembles cobalt and nickel, he placed far away from these. So these are all the demerits of Newland's law of classification. Okay, so that's it about today's session. So in the next session, we will take the Mendeleev's periodic table. What are the merits and demerits of Mendeleev's periodic table? Until then, take care. Bye bye.